Hello YouTube viewers, welcome to my show Computer Wednesday. In today's episode we're going to take a closer look at 5G and I want to explain it to you guys. So you have to understand 4G is very recent technology. I mean, like many of you may be handling your first 4G phone right now as I talk to you, and 4G only came to India in 2018 and like in 2019 everybody finally has it. So why the heck sudden change? Because 3G was there for a few years, but 4G came very quickly and now it's about to go out. So what the hell happened? Well, future needs more data. Basically we went from SD videos to HD videos to 4K video and now at 8K. So at this point in time, we need an insane amount of data. Now that's not for entertainment only. You have to understand we're gonna have soon basically self-driving cars. Sooner or later, today or tomorrow, we're gonna have it. 1 year from now or 5 years from now, we're gonna have it. So we have to have an infrastructure that can handle these puppies also. On top of that, we also have what we call Internet of Things. You can check my detailed video about smart sensors here. Now, Internet of Things is very important and is very important for a lot of other things, including agriculture industry. In that video I talked a lot about it. So we need something that can handle that. Now 4G was like better than 3G because it was upgraded version of it, but it was not multiple times better than that. And this one, basically we're gonna fix the speed issues, basically finally reaching a point where you don't need basically optical fiber connection to your home, or basically cable to your home won't be needed if this works as it intended to, because the speed will be finally in gigabytes per second. So that will be really high. On top of that, they will also design it in such a way that there will be ludicrously low latency. That is one very crucial aspect. Many times you can do a lot of things with basically slow speed but high latency things. So basically low latency, you can handle that, because let's say many security terminals, as in like where you swipe your cards and all that, they want very low latency, because the longer they keep the channel open, the more vulnerable it becomes. So they want to make sure it's very low latency. Now of course there is a limit. 4G can only go to, let's say 5 to 15 millisecond. This puppy want to go to less than 1 millisecond. And on top of that, the throughput. Now this was the first thing that was addressed in 3G. 3G was very good, but it was not designed to serve as many people, because at the time, you have to understand, when 3G came along, people were like, internet on mobile phones were still in megabytes, like oh, you have 200 megabyte for this month. So at that time they were not hoping that entire planet will be connected using smartphones. So it was not built for large throughput. Basically you could not connect hundreds and thousands of people. Now 4G fixed that to some issue, but this again, that capacity is also about to be maxed out. Many of you in India who are using Jio 4G, when Jio 4G came out, the speeds were mind-bogglingly high. Now it's very low, and this has similar things have happened in America, in everywhere basically, where you had like when 4G came out, oh damn, like I'm getting 20-25 Mbps reliably, to like I'm barely getting 5 to 6 Mbps. So the throughput aspect has been fixed into it. And on top of that, because there are so many important things on it, it's not just about Facebook or WhatsApp. Basically, like self-driving car, you have to have good reliable infrastructure for their Internet of Things, especially in industrial world, you have to have reliable things. So they're gonna make it very stable and redundant. So redundant simply means if one pathway from data point A to point B fails, it can recreate another path, maybe a longer path, but it can reconnect itself without causing a lot of damage or delay. So that is why 4G is simply not enough. It flat out does not have enough capacity, speed. Even though speed can be managed to some extent, the latency is a big issue, and the throughput is already been maxed out. So, and it's not very redundant and stable. So okay, 5G, what the heck does that mean? Now first you have to understand, we are using what we call microwave. Every mobile phone you use simply uses microwave. Now the microwave radiation level is very low. That's why you are not cooked when you keep your mobile phone next to your ear, because your microwave oven uses kilowatts of power while your mobile uses microwatts of power. That is why. And on top of that, microwave is a band. Now in that band we have sliced it. Now using that slices, we have what we call bandwidth that is given to some people. Like you can have UHF band, you can have L band, you can have S band, you can have C band. So cellular band is generally at basically low megahertz range to upwards of 4 to 5 gigahertz. Now yeah, if you are familiar with gigahertz, that's your Wi-Fi also. So that's the cellular network. They are generally limited to that. On top of that, the problem with network basically in this terms of radio frequency is very simple. The longer the wavelength, the further it's going to travel. But it does come with a consequence. Consequence being your antenna will become huge, your receiver will become huge. So that's the balancing act. And if you increase the frequency very high, so right now if you are familiar with satellite internet, you can check my video about that here, they're gonna use what we call KU band, KA band or V band. These frequencies are upwards of 12 gigahertz, 18 gigahertz, 27 gigahertz or 40 gigahertz. If somebody goes up to, let's say, V band, the V band is limited to 75 gigahertz. So benefit of that is the amount of data you can transfer from point A to point B would be ludicrously fast, and that will allow you to, like, literally per second you can send upwards of 10 to 30 gigabytes. That's a lot of data that can be transmitted. So that's why we want to use higher frequency. Using higher frequency comes with another advantage. The higher the frequency, the smaller the antenna. So what we're gonna do, as you can see, this is a whole antenna package. It's a very small thing. It's like you can hold it in your hand. So each small node that you see is an antenna, independent antenna. That allows one another clever technique that we can use. It's what we call as phase shifting. Now if you are familiar with 5G, you must have heard it has beam forming. It like only talks to you when it wants to talk to you. All that is happening is that each of the antenna is firing a signal. Now that signal has been offset using a clock. So basically antenna number 1 fires, okay, antenna number 2 fires a little bit late. It's not like boom boom, it's not doing that. It's a tick 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 tick. It's doing that. Now benefit of that in radio frequency is we have something called as constructive interference. Sometimes we call it destructive interference. Basically if you manage it properly, you can have a scenario where you can angle the signal. Basically let's say you have a flat plate, flat antenna, you can literally have signal. If you don't do anything, the signal will be like this. Okay, awesome, no problem. Here's the deal. If you're doing phase shift, you can literally have signal going like this, signal going like this, signal going this, without physically moving it. That's the crucial aspect. That is why we want to use high frequency. Now can it be done with low frequency? Yeah, radio basically military radar does rely on low wave radio waves, but side effect, the antennas are freaking huge and you can't expect that to be like on top of a building. So higher the frequency, higher the data throughput. Smaller the antenna and the receiver, smaller the antenna, the more antennas you can put in a block. Basically this block, the more antenna you can put, the more beam forming you can do. Basically go here, go there, go there. So this allows literally to bypass what we call destructive interference. So that's why if you are familiar with mobile towers, many old mobile towers had this issue that right below the mobile tower you will not receive any signal because there was so much interference from the mobile tower itself, because it was emanating the signal in every direction. It was basically cancelling out. So now that was an old issue, but it's still there to some extent. They are using some clever mathematics or timing frequencies to make sure that they bypass it, but still a big physical issue. This bypasses that because the signal would be, let's say when I did that, let's say 10 watt of signal was going everywhere. Now I made a beam, 8 watt of signal would be there, but that 2 watt would be cancelled out. So it won't interfere with any other signal. And because the high frequency, as in like how many times cycles a second is happening, like 75 gigahertz, you can literally have one signal here, one here, one here, one here from one antenna. One transmitter can do that. So your mobile towers could be like literally size of a laptop box, and as in like a laptop, 15-inch laptop, and it can literally independently, like, okay, one phone is there, one phone is there, one phone is there, one phone is there, one phone is there. It can independently talk to each other while making sure it's not interfering with each other. That is why we want to go higher frequency. So if you are hearing people saying like Huawei made some 5G modem, they are working on 20 gigahertz. So Intel tried to do that, failed. So the Intel is out now, so only Huawei can do that, Samsung can do that, and at this point in time some other companies are also working on it. So at this point 5G modems are not that prevalent, but as of now Nokia is also making some very good technology in terms of transmitter, because of course your mobile is one end of the part and this is more important. So this is why we want to use high frequency. Now you may hear another terms used for high frequency, that is millimeter waves, because if you are familiar with microwave, they are very long. So when it goes to very short range, we call it millimeter wave. That starts at roughly there is no absolute line, roughly from 27 gigahertz to upwards of 300 gigahertz. Now you ended up if you go higher than microwave, you end up in X-rays. So that is why we don't actually want to go to X-ray level. I mean, like, unless you want to give cancer to everybody. So that is why we want to use high frequency. So higher frequency allows you to have 20 gigahertz to 70 gigahertz in case of 5G, and this allows you to make very tiny antennas, which allows you to do phase shifting, which allows you to do beam forming. Now this also allows you to overall cell tower could be very small, as you can see, like these are tiny things. However, this does come with a side effect, because the higher the frequency, the more vulnerable the signal becomes. Now if many of you are familiar with basically a router that has dual signal system, basically 2.5 gigahertz and 5 gigahertz, you must have noticed it already in your day-to-day experience that 5 gigahertz does not travel very far. Now that's an issue here also. The higher the frequency, the lower the range. So basically If you want to go to, let's say, 20 gigahertz, that's why directly nobody is coming and making 70 gigahertz. The range is very limited. Now this, the only way to handle that, because this does allow to make your cell tower very small, you have to have cell tower almost on top of every building. Basically, like, of course it will be small low power one, it's not going to be like, few kilowatts of power going into it, but you're going to have antennas everywhere, every few buildings, every few blocks are very big, but every few building you have to have antenna. That is the most critical aspect. And in rain, good luck, because the rain flat out stops the signal. Like 2.5 gigahertz can go, 5 gigahertz, yeah, it's gonna struggle. But when you are talking about, let's say, anything above 27 gigahertz, basically the Ka band or V band, yeah, these signals don't like rain at all. As in, like, if humidity goes up too much in the atmosphere, the signal won't reach you. So that is why they have to make what we call small cell technology. So if you are familiar with the idea of cell, it's like one mobile tower takes care of an area. Here, that one tower won't be that one quote unquote tower, there will be hundreds of small nodes. The nodes will be very small, and in range terms you are only looking at like few hundred meter, best case scenario. So these are the core aspect of it. This is the physics behind 5G. We're gonna use higher frequency, upwards of 20 to 70. It's gonna make us phase shift small antennas that will allow small cell tower, and you have to litter the whole basically skyline of your city with these towers. One tower will not do it, few towers won't not do it. You have to have hundreds and thousands of towers because of the short range. So that's the core physical aspect of 5G. Then of course there is another aspect of it, what we classify as backbone. Now in terms of backbone, I have provided a video down below that goes in very in depth, and you're gonna enjoy that. But if I want to give you a simplified explanation, think of it this way: it does allow P2P. So basically right now what we have in current infrastructure, everything goes to a central node. Now some people tried what we call spoke and hub system. Basically, if you need to, then only go to hub. If you don't do that. But 4G is like more towards this area, basically everything going to one central point. Side effect, latency. Now this P2P possibility will allow you to do what we call, let's say you are talking to WhatsApp, basically using WhatsApp, and WhatsApp says like that mobile phone that may be on another building, directly go send data to there. That's the crucial aspect. It won't be like, okay, let's read out to server everywhere else and then figure out. No, it's gonna be like, oh, you want to talk someone next to you, boom, direct phone transmission. That is critical, especially for voice call. Now it won't make a too much difference in your basically chatting and all that. You won't notice the latency. However, you will know a tremendous amount of energy saving will be had if this is done for mobile voiceovers. It will make a lot of difference, especially for video calling and all that. This also clears up the core route. Basically, let's say every mobile tower is connected to some central location using, let's say, optical fiber or things like that. That optical fiber will be cleared up for long range communication. This is critical aspect, and this also allows for self-driving car from to talk to another car next to it without going through a cell tower. This is very critical. This allows like cars, because cars have to talk to each car next to you, car back to you, car in front of you, all of them, and they have to communicate very fast. And so you cannot afford latency, and you cannot afford the fact that you have to send the signal to somewhere else and then it's gonna bounce back. So this is possible with 5G. That's why people keep saying that it will change VR, simply because you're gonna have 5G transmitter in your computer and in your basically heads-up display, because it can be point to point. This is very interesting. That is the reason why you are expected to have lower energy demand in terms of 5G tower. Even though it's transmitting much more data, it will need less power. Now full duplex, now this is the most scientific aspect of it. This is the part that took the most amount of time, because phase array, it may sound fancy, but we had phase array in World War II. Basically, once we built radars, we figured out phase array. Now in terms of full duplex, basically every radio signal only does one thing: either it's gonna basically you are sending it or receiving it, output or input. So the way how our modern system was, either it times it, it's like, okay, 1 second talk, then it stops for a second. It's like, hello, 1 second, 1 second, 1 second, 1 second. It's like on off 1 second it's doing. It's time based. Or sometimes they switch the frequency. So basically, in case of normal system, you're gonna have basically, let's say output is sent into like 451, and they're gonna input will be 456. That's why they have two tracks. Now the idea of full duplex is that one track, that one frequency will carry the data back and forth directly. Now if that sounds complicated or convoluted, yeah, it is. It requires a very high level of physics understanding how they are achieving that. That is really complex. This is the golden goose kind of technology. If you can use one frequency to communicate both ways at the same time, that is the reason why you can expect 10 gigabytes per second from a 5G network. That is the reason, because two-way happening in the one stream. Now, it will also employ what we call multiple paths for everything. Basically, everything that they can reroute, they will reroute. The idea for that is, let's say you are doing a voice call and the friend is, in the next town, it's gonna take a simple route for that. But let's say you are doing gaming server, it's gonna create an independent path for gaming. So that way they can have sure like, oh, let's say Google Stadia server is somewhere here. Okay, all the data to gaming system will be recreated that path. So you will have minimal latency and also energy saving, everything. And this Wi-Fi's next standard will also use these high frequencies, so they can directly switch over from, let's say you reached a point where your Wi-Fi network is strong, it will directly switch over and you won't even notice that your mobile phone switched over it. So these sort of thing will also make the system very redundant. So let's say one mobile tower failed, everything around you that can accept the signal will accept the signal and reroute it, because the protocols that are behind the scene, they are built in such a way that it can handle it. So that is the critical aspect. The signal will not go down unless something big or major or something very big happened. It will not go down. Now every aspect of this system is built on the knowledge of 4G. Basically 4G supposed to be this awesome thing, and it did become the awesome thing, but it never truly became the thing that people wanted. So the biggest hurdle with that was 4G infrastructure. Now on top of that infrastructure, now there is another aspect of it, like they never mass produced it. Another aspect was that because it was very complex, to solve that complexity issues, so anybody can build it, they come up with the idea what we call software defined network. Basically every aspect of the software, basically how the IP routing is gonna done, how the peer-to-peer communication is gonna, all these are a software block. So they don't have to build what we call custom ASICs, basically application specific semiconductors. They don't have to do that. So that reduces the cost. So they're gonna have one big processor and you're gonna software design whatever you need. So benefit, it's gonna simplify the manufacturing aspect of it and tailor making the service. Basically, let's say you are dealing with a factory which have hundreds of smart sensors which are talking to you. Your requirement is completely different with someone who's handling mobile phone. So you can literally in software buy a same hardware, basically buy the same hardware that let's say Verizon is gonna buy. You can buy the same hardware and be like, okay, so I will software code it, or like the company that sold you the smart sensor, they can be like, okay, use this firmware. That is the critical aspect. Infrastructure is flexible on a software level, on a core level, because the modern processors are so fast that there is no latency to worry about. This can be done. This is the new advantage on top of that. And this also has what we call context aware resource allocation. Basically, if you're gaming, it's gonna be like, okay, let's give it as fast of a path as possible. If you're doing voice call, it will be higher priority. If you are vehicle transmission, it's gonna give you absolute priority. So that way it can know which signal to cut. Let's say you are watching YouTube, it's gonna cut your signal rather than cutting the signal of a, let's say, a smart sensor that is monitoring someone's health. So it is very context aware. This is this is how they can ensure the redundancy is maintained. Basically, you're not gonna cry a lot if your YouTube gets cut versus if your self-driving car loses the signal. So this is the backbone aspect of it. The signal aspect, you are going high frequency, but in the backbone there has been a lot of development. They learned a lot from 4G development, because 4G inherently was just 3G taken to the next level. This is completely different. That's why the gigahertz is not going from 6 gigahertz to 8 gigahertz. This is going to like freaking 24 gigahertz. They are making a huge jump. So backbone has been redone thoroughly. So are there any consequences of this? Yes. The first consequence, we really don't know what happens to your health. Now some people say millimeter wave has been used in security industry while some time, and not to mention if it was unsafe for human, the people who were experimenting with 5G modem and router, they would have been dead. So it's not lethal to us, but we do not know long-term consequence of this, because the 5G technology itself, the hardware itself is very young. It's not like we have been experimenting with this for like, let's say 30-40 years. It's very new, so we do not know. Now the primary thing that people are, this will increase, this will not cause any deep damage, because inherently millimeter wave cannot go very deep. So inherently it won't cause any damage. However, it can increase the risk of skin cancer. It will not give you brain cancer, testicular cancer or anything of that nature, but it can increase the risk of skin cancer. That is unspecified as of now, but that's the people say like, rough idea, rough estimate, because of how millimeter wave works. On top of that, you forget your privacy. If you are talking about 5G, inherently 5G works by what we call beamforming. Basically it knows where you are, it's pointing its antenna, quote unquote, to you. So benefit of that is like, if police service wants to track you, the moment you pick up the phone, the moment your phone is active, the mobile tower already knows where you are. and I mean in three-dimensional space. There is no triangulation here, there is no timing data. It already knows. By default, it already knows. So they will be like, okay, this mobile number, let's say my mobile number, they want to be like, okay, let's track this phone. This mobile phone would be at any given moment in time, would be in communication with any cell tower. That cell tower would be like, okay, cell tower number A. Okay, that where is that cell tower number A in map? Okay, point 1. Okay, they know that location, obviously. Then they're gonna be like, I'm using antenna number B. Let's say antenna number B is here. They will know that physical location of that. Now antenna B is going to give you that exact data, like from my point of view, as in antenna B, 30° left, 30° down. So that way they inherently know where you are, and because it's also timing the signal, basically how long that signal takes coming back and forth, it also knows that distance. So basically this antenna, the moment you communicate to it, already knows your position in three-dimensional space. Basically, if in a building, it's not gonna say, oh, you are in this building. It's gonna say like, yeah, in the 4th floor in the left bathroom. It's that accurate. So forget about your location. Like, it knows where you are by default. It has to know. And you were like, what if I bounce the signal? They thought of that. The signal bouncing is that is why it has timing system. So it can time is also bypasses interference. But if you're like, unless you can change space-time and space-time continue and change the speed of light, they know. Basically, if police wants to know, they know your exact location if your phone is on. It does not need to be like, communicating or doing anything. If it's on, they know your space in 3 dimension. So like if you are in 8th floor, they know you are in 8th floor. In which bathroom you are in, they know that. So forget about your location. They know it. They don't need GPS. They know it by default. Now, coverage would be horrible in this, because I already specified the millimeter wave really don't like water and they can't go with it. Now you might be like, wouldn't the fact we're gonna have multiple small towers covering the whole area and giving us good signal? No. 4G is supposed to do that. 4G is supposed to be like, whoever engineer built 4G, they were not stupid, they were not idiot. They built it amazingly. The 4G network supposed to be able to handle hundreds of clients. But here's the problem. You're supposed to have few towers. You're not supposed to like put one tower in one country and like forget about it. And every ISP is doing that. It's like, Verizon put like 5 towers there and that's it. You're not gonna serve New York with 5 towers, you need 500. And it's still profitable. It's not that, oh, if they put 500 it would be in loss. No, they're just lazy, and they are inherently doing this simply because they can force you to go to quote unquote 5G. And in first few days 5G will be very good because it will be very expensive and only few people will be using it, and at that point they will be like, yeah, 5G, it's limited, we have to upgrade to 6G. So this creates a vicious cycle. Before they max out the technology, before they can give you a good service, they're gonna say, oh, the service is bad because technology is bad, because we have to wait for next technology. So this is really bad. Like, if you are expecting 5G is going to give you a good coverage, forget about it. Flat out, forget about it. And this has a very bad business model problem to it. Inherently, if you are running a business, especially like a mobile tower, you want to have one place or few places to handle. You don't want like, I have to go to on top of every building to check my antennas. You want like, okay, one place, go there, what's wrong, how the power is happening. You're going to have UPS here, you're going to have backup here. If every place you have to have few antennas, that makes a very bad business decision. Even though each itself can be cheap, you have to make sure that they are maintained. So that creates a very bad basically business sense, because you need to have these every few basically blocks, not even few blocks, like few buildings. So imagine that like whoever is in charge of handling the mobile towers, they have to do a lot of work. And this is not them being lazy or bad, like they have to do it. Like right now their business model is like, okay, we're gonna have, let's say this is a small town, we're gonna have, let's say 10 mobile tower. That 10 will be turned into 100. Now of course it will be very simple, like okay, power plug, battery backup, whatever have you, but still it's 100 independent physically different point. You will spend time just going there, like your time would be wasted just trying to go there. So that is the aspect of it. It has very bad business model that will encourage them to put very few antennas that will give you basically very poor coverage. So 5G is not everything is awesome about right now, because forget about your location data, it's flat out in there, and health effects we do not know. Now in Netherlands they tried 5G and it killed all the birds, so that's also there. And yes, it is very common. It's a known fact that mobile towers kills bird. Like we do not know to what extent and to what speed, because it has made few bird species flat out extinct. So, and if it can kill pigeons, entire basically Britain will be like, get us 5G right now. They hate pigeons, and I do understand that. Like if in India they can kill crow, I'm like, get that 5G right now. So we do not know, but unfortunately it only affects small birds much more effectively than big birds. So yeah, big birds still gonna survive, but small birds will be destroyed. So we really don't know the health effect. Forget about your privacy of your location, and coverage won't be good. Like in principle, they will be good. Like because 4G is very good, but they never maxed it out. They never used it to its capacity. Like it was meant for like, okay, a mobile tower has what we call a backup capacity. So let's say it can give you very good signal to 100 mobile phone, but it can handle 1000. Mobile companies started to use that. Oh, it can handle 1000. No, 1000 is there at minimal rate. Like that is like just making sure you are communicating to each other. That's why many times if you see slow signals, basically slow data transfer, but you still see the signal strength to be maximum. That's the reason, because the cell tower is like exhausted. It's like, dude, I'm meant to handle 100 people, not meant to handle like 1000 people doing YouTube at that same time. So don't worry, don't even think about you're gonna get good coverage with 4G, pardon me, 5G. So this was my presentation on 5G. I hope you liked it, learned from it. In that case, please leave a like, click the ads that are shown in this video, that will directly help me. And if you didn't like it, don't worry about it, you can press dislike. I would urge you to press this twice to show me your extra disappointment, and leave a comment because I reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.